that they're always here before the class starts, and so everybody's like camping out in the hallways. And it's pretty incredible because I've never been at a university where students are standing and wait till to learn. And so I can imagine that. But when it's time to go, you guys are like, let's go. It's like, whoa. All right. So I'm gonna set this up. So here's the idea. You have everybody's like all silent. So you have a good that we're producing, which is education. And you can think about that as test scores. You can think about that as like the sociability of the kids. You can think about that as any number of things. And there are going to be multiple inputs into that production process. It could be teachers, it could be facilities, it could be peers, it could be any number of things. And each of those inputs are going to be costly. So to hire better teachers, or even to hire more teachers at the same pay rate, it's going to cost you more money. To get more computers, it's going to cost you more money too. And the question is, if you have a constraint in terms of like what the cost of those inputs are, and you also know what the production technology is, which is like what's the right mix of teachers and students, then you can figure out what's the optimal amount of money to spend on each of those inputs. Right? And so that's how you should think about your production function from your previous classes. How many of you have seen production functions before? That's exactly, we want to produce student quality and give all of these different inputs that cost different amounts of money. And on the margin, we're going to be equalizing, well, what's the marginal rate of, we're going to be setting the marginal rate of transformation, which is going to be like the ratio of like the marginal changes in output per unit dollar of that input. And we're going to equalize that across all of the different inputs. When we come to class the next time, what I'll do is I'll start off with a quick example of that, and then I still have 2 minutes. And then I will be 1 minute early. And then what we're going to do is we're going to transition to game theory. And just to set up game theory, how many of you guys have heard of game theory before? Okay. So far, we've been considering contexts in which Sandra's choosing X and Y. And Sandra only cares about, Sandra's choices are only affected, Sandra's utility are only affected by her choices. But there could be other contexts in which the choices of other students or other people affect Sandra's outcome. So let me put this in a concrete way. So in this class, there's a flat grading scale. And so if you choose to help each other with the homeworks and study together, and all of you scored above an 85, how many of you will get A's? Say it again? Everyone will get A's, right? But if you were in a class where it was curved, then by you helping somebody else, if they get a higher score, it potentially can push you down the curve, right? And so you get the strategic interaction where you're like, okay, if I help this person, I'm going to be better, but they're going to be better too. And so you might want to help people who are going to be better without affecting you, right? But somebody who you think by helping them, you're going to make them better than you might not want to help them. And you get these kinds of strategic interactions. And so this is what happens in game theory, is when we think about the way in which one person's actions affect the payoff or utility of somebody else. That's it. Have a great day. All the best with your homework.